Hello everyone and welcome back to Space and Mystery. Today, we're diving into the wild world of solar flares and space weather. Our sun does more than just light up the sky, it's constantly sending out streams of energy and particles that impact Earth and our entire solar system. So, what exactly are solar flares and why do we need to pay attention to space weather? Let's find out. To understand solar flares, we need to start with the sun itself. The sun's surface, or photosphere, is a turbulent sea of superheated plasma where charged particles interact with powerful magnetic fields. These magnetic fields can twist, snap, and release massive amounts of energy. The outer layer of the sun's atmosphere, called the corona, is also extremely active, and it's here where most solar flares and other solar phenomena are generated. Think of the sun as a huge spinning ball of magnetic energy. And sometimes that energy has to find a way to release itself. A solar flare is a sudden, intense burst of radiation caused by the release of magnetic energy from the sun's atmosphere. These flares happen when magnetic field lines on the sun's surface cross and realign, creating a violent explosion that releases energy equivalent to millions of nuclear bombs. Solar flares come in different intensities, from small ones called X-class to the biggest, class flares. X-class flares are the most powerful and can cause serious disruptions to Earth's technology and communication systems. So, how do solar flares impact us here on Earth? Well, when a solar flare occurs, it sends out bursts of electromagnetic radiation. Some of this energy can reach Earth in just 8 minutes, impacting radio communications, GPS systems, and even power grids. High-energy X-rays from a flare can interfere with high-frequency radio signals, causing radio blackouts. Pilots, mariners, and emergency services who rely on long-distance radio communication can be affected by these blackouts, especially in the areas directly facing the sun. Along with solar flares, the sun also produces coronal mass ejections, or CMEs. These are huge bubbles of plasma and magnetic field lines that get blasted out into space. While a solar flare sends energy, a CME sends particles, mostly protons and electrons, hurtling toward Earth at high speeds. If a CME is directed towards Earth, it can cause what's known as a geomagnetic storm. When the charged particles from a CME collide with Earth's magnetic field, they can trigger beautiful auroras, but they can also cause disturbances to satellites, power grids, and even astronaut safety. Earth has a magnetic field known as the magnetosphere that protects us from most of the sun's harmful energy and particles. The magnetosphere acts as a shield, deflecting many of the charged particles. But during intense solar storms, that shield can get pushed around and even open up in places, letting some particles through. When these particles enter our atmosphere, they cause increased currents in our ionosphere, which can lead to issues with GPS, satellite communication, and even power grid disruptions. Strong geomagnetic storms can overload power grids and cause blackouts. The sun goes through an 11-year solar cycle where its magnetic activity increases and decreases. At the peak of the cycle, known as solar maximum, we see more sunspots, solar flares, and CMEs. At solar minimum, there's much less activity. Scientists track this cycle to help predict when we might see more intense space weather. We're currently entering a new solar maximum, which means we can expect more solar flares and potential geomagnetic storms over the next few years. Monitoring this activity is crucial for preparing and protecting our technology here on Earth. To monitor solar activity, scientists use solar observatories like SOHO and the Solar Dynamics Observatory, or SDO, which constantly watch the sun. These observatories give us real-time data on solar flares, CMEs, and other solar events, allowing us to predict and prepare for any possible impacts on Earth. Data from these observatories help scientists forecast space weather, allowing operators of power grids, satellites, and communication networks to prepare for potential disruptions. Here's a fun but mind-blowing fact. The most powerful solar storm ever recorded was the Carrington event of 1859. It was so strong that it caused telegraph systems around the world to spark and catch fire, and auroras were visible as far south as the Caribbean. Scientists believe that if a storm of that magnitude happened today, it could cause widespread blackouts and disrupt technology for weeks. Luckily, we're better prepared now. Power companies, satellite operators, and even airlines have strategies to mitigate space weather impacts. For example, when a strong solar storm is predicted, airlines can reroute flights away from polar regions, where radiation levels would be higher. While we can't stop solar flares or CMEs, understanding and monitoring them gives us time to protect our technology and ensure that our systems remain resilient. To recap, solar flares are bursts of radiation from the sun, while CMEs are massive clouds of charged particles. Both can impact Earth's technology, but thanks to our magnetic field and space weather forecasting, we're well prepared to handle them. Thanks for joining us on this journey into space weather. If you learned something new, hit that like button and subscribe to Space and Mystery for more videos on the wonders and hazards of space. Have any questions about solar storms or space weather? Drop them in the comments below and we'll see you next time.